All right, so I think this is recording. Let's take a look here at number 6. We want to solve this triangle. They give us half the information, so we want to find the other half. By half, I mean when we solve a triangle, we want to find the measure of the three angles and the length of the three sides. So let's make a sketch here. We have this angle B that's given as 28.9 degrees. We have the length of B being 12.7 and the length of A being 15.8. So this is our ambiguous case, two sides and the non-included angle. The first thing I do is compare the 12.7 against 15.8. It's smaller. So if it were larger, I would know that line would extend all the way out and there'd be one triangle. Now that so it's smaller, I want to know if it's too small. I need to find the height of that vertex because I don't know if 12.7 is long enough to reach this other side. So let's call that H. If we take the sine of 28.9 degrees, it's the opposite leg over the hypotenuse. If we multiply both sides by 15.8, we can find this height. So I'm getting that this height will be approximately 15.8 times the sine at 28.9, 7.64. All right, so this is definitely long enough. This 12.7 is definitely long enough to cover that height. So what we're going to have then, I'm going to erase this. We know that if we treat this like a hinge, where this 12.7 is like the pendulum of a clock, if it swings out this direction, that's going to form one triangle. If it swings in the other direction, if it swings in this way, it's going to be a second triangle. So we need to find the measurements of these triangles. Well, the given information is going to be the same in each triangle. So let's come over and start with the pair that we're given. We're given the pair of B's. So we're going to start with the sine of B over B is equal to the sine of A over A. If we replace the known, substitute in these known values, on the left-hand side we know both of these. On the right-hand side we know the length of A, but we don't know the measure of angle A. So let's use our scientific calculator. Double check that we're in degrees. We're set to round to 2 decimals, and that's fine. If we find first this ratio by taking 15.8 times the sine of 28.9, don't forget to close that parenthesis, divide it by 12.7. There's our ratio. If we take the inverse sine, I'm getting 36.96 degrees. Now, we know that's a quadrant 1 angle, and that we're going to be able to find a quadrant 2 angle in just a minute, and that's going to be for our second triangle. Shrink this up a little bit. So now I know 2 of the 3 angles, and I can find the measure of angle C by my triangle angle sum theorem. I know inside of any triangle that the angles have to add up to 180. So if we subtract the sum of 28.9 and 36.96 away from 180, we'll get that measure of angle C. So we've got 180 minus the sum of the given angle and the angle that we just found. So I'm getting 114.14. Okay, so now we know the 3 angles, we know 2 of the sides. Let's return back to our ratio. And now we'll work with the C's, the angle C and the length C. We found the measure of this angle C to be 114.14, and we're trying to find the length of C. If we cross multiply, what do we get? We get this 12.7 times the sine of 114.14. Along the green diagonal, I multiply those, but then I'm going to immediately divide by the sine to get the C by itself. Don't forget to close that parenthesis. .98 is the length of that side. So we have solved one triangle. All right, now you've got that recorded. Let's come back. For the very first time that we used the calculator, it didn't tell us the whole information. Remember, it only returned a quadrant 1 angle. And we know that in quadrant 2 is another angle that has the same y coordinate. So the angle that it found, it looked between -90 and +90. It looked on the right half of this unit circle, and it found this angle in quadrant 1 that we'll use as a reference angle. And we need to find in this quadrant 2 here is another point that has the same y coordinate as the point in quadrant 1. So we need to find this angle, and we'll find that angle for our second A by taking 180 minus this. We'll treat it as a reference angle. $143.04. All right, so now let's go back to our known ratio, the sine of b over b, and oh, well, wait a minute. Before I do that, let's find the measure of angle C. We know it's 180 minus the measure of the given angle, which was 28.9, and the sum of this 143.04. .06. So now we have the three angle measures for the second triangle, and we need to find the length of side B. Shrink this up. So let's return to that ratio of the sine of b over b, and we know it's equal to the sine of c over c. So we've got our 28.9. That was a given angle and a given length, and we found a new quadrant 2 angle. Oops, that's not quadrant 2. 143. Oh, wait a minute. I want angle C. I do want the 8.06 because I'm trying to find the length of C. I'm given the length of A and B, so yeah, I need this. So let's take the cross product. When I multiply along that gold diagonal there, I get 12.7 times the sine of 8.06. When I multiply along the green diagonal, I have C times the sine, but then I'm going to turn around and divide by that sine, so I get the C by itself. And of course, this is the second length because we're working on that second triangle. We've got 12.7 times the sine of 8.06. Don't forget to close that parenthesis. And the sine of 28.9, 3.68. All right, well, that ought to do it. I hope that helps, and I'll talk to you later. Bye.